Okay, the last question of this paper is question number 7, A part. Propanoic acid can be represented by the formula CH3CH2COOH. Part 1. Propanoic acid reacts with methanol to produce an ester. Name the ester formed and draw its displayed formula. So, to name the ester, the general naming for the ester is alkyl, alkane, and then we end it on O8. So alkyl is from alcohol part. So for alcohol I am writing OL all for the indication from all part. And for alkane it is from oic acid. Oic acid means carboxylic acid. And O8 is actually the representation for the ester functional group. So we have meth from the alcohol part. So to name it in the form of alkyl, it would be methyl. And the second name from the carboxylic acid path is the propanoic acid. So the name would be methyl propane, and then it would end on O8. Now the last thing is the displayed formula. So for the displayed formula, we have to show all the atoms and all the bonds. So we'll follow with the same pattern, methyl propanoate. So methyl means one carbon, so carbon number 1. And this carbon is bonded with oxygen, so oxygen. So from whenever we have to make the ester, we remove the H from the alcohol part and the OH from the carboxylic acid part. So there are 3 carbons in the carboxylic acid, which is propanoic acid. So the carbonyl carbon will be directly attached with the alcoholic oxygen like this, and this carbon is attached with 2 more carbon atoms. So this is the basic skeleton, and this is the ester major functional group, carbonyl carbon bonded with oxygen. Now we have to fulfill the valency of each carbon. Each carbon atom needed 4 bonds. So accordingly we will write the bonds and then the hydrogen atoms in front of each bond. So this is the displayed formula of methyl propanoate. Okay, next part is part 2. Propanoic acid is a weak acid. Chemical equation is mentioned. Explain how this equation shows that CH3CH2COH is an acid by referring to proton transfer. So for acid, proton is transferred from acid to water, because if you look into the product side, the carboxylic acid removes the hydrogen and the water has accepted that hydrogen. So we can write it, proton is transferred from acid to water. Okay, next part is CH3CH2COH is a weak acid. So how can we know that this is a weak acid? Because the reaction does not go to completion, and the clear identification is this reversible arrow. So whenever we see a reversible arrow for the acidic part, it means it's a hint for us that this is a weak acid. So we can say that the acid is not fully dissociated, or in other words we can say that it is not fully ionized, or we can say the reaction does not go to completion. Now the next part 3, propanoic acid reacts with magnesium. Name the 2 products of this reaction. So consider it as a general reaction. So whenever any acid reacts with the metal, it produces salt and hydrogen gas. So examiner uses what? Name the product. So we are not going to write any formula. So the product, the salt that is produced in this case is magnesium propanoate. So we will write a word, magnesium propanoate. and the other product is a gas, which is hydrogen. So we will write the name of hydrogen like this. Okay, the next part is part 4. Magnesium is a solid at room temperature. Describe the motion and separation of the particles in a solid. So if we are talking about two things here, the motion as well as the separation of the particles in the solid state. So in the solid, particles only vibrate. So the motion is particles only vibrate. And for the separation, it means how the particles are arranged with each other. So they are closely packed together, or we can use a word, they are touching each other, or a word tightly packed can also be used here. Okay, next part B. Figure 7.1 shows the simplified structure of two molecules that combine to form polyamide. Polyamide means when carbonyl carbon attached with nitrogen that is bonded to hydrogen. So this is the basic skeleton of the polyamide functional group. So two monomers are given. Now part 1. Complete the diagram in figure 7.2 to show the structures of two repeat units of this polyamide. Show all the atoms and all the bonds in the linkages. So if you look into the above polymer, the monomers to make the polymers, whenever we see the carboxylic acid, the OH is removed from the carboxylic part. So we will remove the OH from the carboxylic acid part, and from the amine part we remove the hydrogen atoms, only one hydrogen atom. So, and keep this boxes pattern in your mind. So I have first the unfilled box. So we will draw nitrogen that is bonded with hydrogen on both the side like this, and then we have to draw extended line and then extended line, and to the shaded line we have a carbonyl carbon. So C double bond O that is bonded with nitrogen, and then again we have C double bond O extended line, then unfilled box, it means it is attached with the nitrogen and then hydrogen and connect both the monomers together. Then same thing, nitrogen and carbonyl and then extended line. So this is how we have to draw the two repeat units of the above monomers to make the polyamide linkage. So in all the structure, this is the amide linkage, and as there are many amide linkage, that's why we are using a word polyamide. Okay, the next part is polyamide are polymers. State the meaning of the term polymer. So the polymers are basically large molecules built from many smaller molecules called monomers. So it means when many small molecules, like such as the monomers, when they are connected together, they give a one large molecule, and the large molecule is called a polymer. Okay, the next part is, which is the last part of this paper, part 3. Polyamides are condensation polymers. State one difference between the condensation polymers and addition polymer. So condensation polymers, whenever the monomers are combined together, they releases one small molecule, while for the addition polymerization there is no small molecule eliminated, only one product is formed. So you can use any difference here, or either the elimination of the small molecule, or you can say only one single product is formed in the addition polymerization. So we can say that only one product is formed in addition polymerization. So that's all for this paper.